In our previous videos, we talked about how XGBoost uses a team of experts approach, how it builds the trees in a sequence, and how the learning rate ensures our model takes small, steady steps by partially correcting the errors. In this video, we'll open up the equations engine to reveal the two key mechanisms that keep our trees modest and robust. Lambda, which shrinks the leaf corrections, and gamma, which controls the cost of splitting a node. By the end, you'll see how these controls, along with everything else we have learned, make XGBoost the extreme algorithm that dominates machine learning competitions. Let's get started. Welcome to Scovia Labs, where we make AI concepts feel like everyday ideas. Now that we understand gradient boosting and learning rate, let's talk about tree capacity and stopping. There are a few knobs that we can use to control how the tree grows. The first one is setting a limit on either the tree depth or the number of maximum leaves allowed. Smaller trees ensure gentler local corrections. Another knob is the gamma value, which sets a condition that a node should only be split if the gain is big enough. If the gain from splitting is not big enough, the node is not allowed to split and becomes a child node instead. These are metrics to control tree growth, right? Now there's another metric that you could use as an early stopping condition where you could stop adding trees if the validation metric does not show improvement. Next, let's talk about regularization, where it lives in the equation and what it does. Our earlier equation for calculation of similarity looked like this. When regularization is added, the new equation has a lambda value in the denominator. This lambda acts like adding virtual points to every leaf, which makes the similarity shrink. As a result, only the strong, consistent residuals look attractive. Similarly, the sum of squared error value before adding any regularization looked like this. And this calculation after regularization looks like this. The previous equation for gain that we saw looked like this. And now the new equation, once you add regularization and the gamma value, which we talked about before, the new gain would look like this. The gamma value here is like a toll that's added to the gain calculation. You only split if the gain is bigger than gamma. Otherwise, the gain becomes negative and there's no point in splitting the tree further. Idea is that lambda shrinks leaf corrections towards 0 and gamma charges for making a new leaf. Together, they discourage tiny, noisy splits and keep the tree modest. In summary, XGBoost is still gradient boosting. Many small trees that fix what the current model gets wrong. But extreme means it's tuned for power, control, and scale. It uses both the error and its curvature to set leaf values and picks splits so each tree corrects the most important mistakes faster. It bakes in regularization and handles missing or sparse data natively, reducing the overfit. And it's heavily optimized, so it trains much faster on large datasets. So that's a wrap. Thanks for joining us on Scovia Labs. Hit that subscribe button for more insights, and as always, stay curious.